Hello, am I audible?
Yes, ma'am.
Okay. So last lecture we have seen some examples based on PCNF, that is principal conjunctive normal form. So can anybody tell me how we can find PCNF using truth table? What are the rules when we are considering value of that variable in its original form and when we are taking complement? Yes. So for PCNF, what we have seen, if that variable is in its original form, then we are assigning its value as 0. And if there is complement, then we are taking value of that variable as 1. Okay. So likewise, if your truth table is containing, that is last column of that truth table is containing value 1, then we have, yes, hello, hello,
Yes,
yes,
ma'am.
sir.
Yes, ma'am.
Okay. So here we have seen this example last lecture. Just we have seen by using truth table. So what is this given function? F of xyz is equals to x or z and y. Okay. So we have to solve this one using truth table method. So first of all, we have to see how many variables are there in given function, and those variables are x, y, z. Means what? Again, there will be 2 raised to 3, that is 8 possible combinations of truth values, and those we have written over here. It is 1, 2, 3, 4, 4 ones and 4 zeros. Like again for y, 2 ones, 2 zeros, and for z, 1 0, 1 0. So now we have to see what is this function x or z and y. So first of all we have to make one column for x or z, and last one for this whole function as x or z and y. Now find what is the value of x or y. X or y means what? Or operation means what? Again, final value will be 0 if both the values of x and z are 0. Otherwise, it is 1. So, check here 1 1 1 1 0 1 1 1 1 1 0 1 0 1 1 0 0 0 again 0 1 1 and last one 0 0 0. Now we have to find the value for this last column. So we have to take AND operation of these two columns, that is y and x or z. So what is the condition for this AND operation? If both the values are 1, then only final value will be 1. Otherwise it is 0. So check here 1 1 1 1 1 1, then 0 1 0, again 0 1 0, 1 1 1, 1 0 0, 0 1 0, and 0 0 0. So for this PCNF, we are going to check where we have written 0 in the last column, and for those values we are checking for max terms. So check here, first 0 is written here, and what are the values of x, y, z for this 0? So for this 0, values of x, y, z are 1, 0, 1. So according to our rule, what is this max term? First max term काय येईल मग? Our rule is if we have written 1, then we have to take complement of that variable. And if value of that variable is 0, then we have to consider it in original form.
X complement, Y, Z complement.
And what is the symbol or operation to connect these variables?
XOR.
Yes, correct. XOR. That is X complement XOR Y XOR Z complement. This is our first max term. So likewise, we can define remaining ones. For this second zero, what is the max term?
X complement XOR Y XOR Z.
Yes, correct. And for next one,
Next one, X XOR Y complement XOR Z.
correct. Next,
X XOR Y XOR Z complement. And last one, X XOR Y XOR Z.
Z. Okay, correct. So these are all max terms. Now I have to connect all these max terms by this symbol.
Star operation.
Product. Yes, that is star operation, product symbol. So that we have written here. And this is required product of sum form for this given expression. So this is by using truth table method. Now we have to solve same example using algebraic method. That is given here. What is our given expression? X or Z and Y. Okay. Now product of sum is what? This is product. So we have to consider these two are separate terms. That is X or Z, this is first term and Y is another term. And these two terms are connected by AND operation. So now we have to find product of sum for this same example. Now first of all we will think about this bracket. So X or Z. So again we have to think which one is the missing variable. So here missing variable is Y. So we have to add it. So how we can add X or Z or Y and Y's complement. So this is the rule. In this way we can add missing terms in PCNM. And that symbol is written here and Y. And for this Y, two terms are missing, X and Z. But at a time we can add only one term. That's why I have considered here term to be added is Z. So how we have added it? Or Z and Z complement. Okay. So up till now it is fine.
Yes, ma'am.
Yes, ma'am.
Okay. So now we have to apply distributive law. So again, X or Y or Z, this is our first bracket, and X or Y's complement or Z, this is second bracket. Just we have applied distributive law, nothing else. And now again we have to apply here distributive law as Y or Z, this is one bracket, and Y or Z complement. Okay. So again check here for these first two brackets. It is fine because here every bracket is containing all three symbols. But if you consider this one, these two terms, here again X is missing. And so we have to add it. So for these two terms, we have to add X. So how we have added? Or X and X complement. So again, for this whole bracket, we have to apply distributive law. So again, X or Y or Z, this is one term, and X complement or Y or Z, this is another bracket. Now, again we have to check for this remaining bracket. X or Y or Z complement, this is one bracket, and X complement or Y or Z complement, this is another bracket. So means what? Again here these two terms gets splitted into four terms. Okay, after applying distributive law. Now this is our answer. So check whether there is any repeated term. So here X or Y or Z, this is term which is repeated. So we are going to consider it once. So your final answer will contain 1, 2, 3, 4 and 5. 5 terms will be there in your final answer. And that is written here. So this is required product of sum for this given expression. Have you understood this example?
Yes, ma'am.
Yes, ma'am.
Okay. This example is also second one. We have just seen truth table method for this second example. Have you seen for this algebraic method? I think I have given you exercise for this one. Solve this one by algebraic method. Has anybody tried?
Yes, ma'am.
So can you tell me what is your answer? Then we will verify.
Star 0, 1, 4, 5, 6.
Uh, 0, 1. Let's check here. 0, 0, 0, 0, 0, 1. 0, 1. Okay. 1, 0, 0. 1, 0, 0. This is for which one?
4.
4. Yes, 4. 1, 1, 0. And
6.
1, 0, 1. 5 and 6. Okay, correct. So we will solve it. What is our given function? F of x, y, z is equals to x or y and x complement or z and y or z complement. And we have to convert this one into product of sum formula. So check here, product is given. Yes, product is there. Also sum is there. So this is in correct form. But just we have to transform into in a form such that every bracket will contain all three variables. Now check here, first bracket is containing two variables, z is missing, and for second bracket y is missing, and for third bracket x is missing. So we have to add it by ourselves. So check first bracket x or y. So for this bracket we are going to add term z. So or z and z complement. So this is new term we have added, and x complement or z, and for this one y is missing, so we have added it as or y and y's complement. And for this last bracket x is missing, so that we have added as y or z complement or x and x complement. Now just we have to apply distributive law here. So you have to tell me how we can apply it. डिस्ट्रीब्युटिव्ह लॉ अप्लाय करा आणि काय ब्रॅकेट्स येतील ते सांगा मला. फर्स्ट ऑफ ऑल टेल मी अबाउट दिस फर्स्ट ब्रॅकेट.
X or Y or Z.
Yes, and next one.
And X or Y or Z complement.
Yes, correct. And now for this second bracket.
X complement
X
or y or
Yes. Continue.
and x complement or y complement or z.
Good. And for this last one.
Y or Z complement or X.
Okay. And
X complement or y or z complement.
okay. So again, we have to arrange this one into ascending order, that is in sequence of x, y, z. So check here, I have done here. So again, we have to think about repeated term. So here one term is repeated, x or y or z complement. So that term we have to consider only once. So after solving this, you will get 5 terms. So again, you can convert this one into binary format. So if variable is in its original form, then we have to assign its value as 0, and if complement is there, then we have to assign value as 1. So likewise, if you solve, then you will get its binary format also. So have we understood this PCNF and PDNF?
Yes, ma'am.
Okay, so I think this much examples are enough for this PDNF and PCNF, because same terms we are going to repeat in unit number 2. So after completion of this chapter, we are going to start with unit number 2. So at that time also, you have to see examples based on PCNF and PDNF. There also you will get more examples on these 2 points. So just I will summarize PDNF and PCNF. So listen carefully. PDNF, for this PDNF, minterm is associated, and how we can write the minterm? Suppose there are 2 variables x1 and x2, then we can define minterms as x1 star x2, then x1 complement star x2, then x1 star x2 complement, and last one x1 complement star x2 complement. So there is one formula to find number of minterms, and that formula is 2 raised to n. Again, n is number of variables. So 2 raised to 2, that is equals to 4. So again, this PDNF is called as sum of product canonical form. So sum of product means what? Inside the bracket star should be there, outside the bracket XOR should be there. That is called as sum of product form. And again, for this, every bracket must contain all required variables. Then only that format is called as correct format. So while solving this one by using truth table method, what is the procedure? First, we will find truth table for a given expression, and then we will look into final column. So how we can assign the values? So if your final column is containing 1, then we are going to considering only those values. If your final column is containing 4 ones, then only for those 4 ones we are looking for what are the values of x, y, z. So again, what is the rule? If value of that variable is 1, then we have to consider that one is in correct form. As well, if that variable is containing value as 0, then we have to take its complement. So likewise, we can find the PDNF for given expression using truth table method. So now we will summarize what about PCNF. So for this PCNF, max terms are associated with PCNF, and again there is same formula to find the number of max terms, that is 2 raised to n. So if your expression is containing 2 variables, then there will be 4 possible max terms. So again we can find the product of sum formula from truth table method. So again, procedure is, first of all we have to find truth table for given expression, and then we have to look into final column, that is for function f. So again we have to check where we have written zeros. Then for that particular 0, we have to look for what are the values of x, y, z. So if value of that variable x is 1, then we have to consider that's complement, and if value of that variable is 0, then we have to consider that variable in its original form. So likewise, we can find product of sum. So again, for this product of sum, outside the bracket product should be there, and inside the bracket sum should be there. So these are the some tips to find sum of product and product of sum, or we can say PDNF and PCNF format for given expression. Now we will continue with some remaining points from this chapter. So next point is value of Boolean expressions and Boolean functions. So this is the last point from this chapter. We will see how we can find the value of Boolean expression from given diagram. So here one question is given. Find the value of, this is given Boolean expression as x1 star x2 star x1 star x4 XOR x2 complement XOR x3 star x1 complement. Okay, so this is given expression, and from this we have to find what is the value for this expression. So here they have given value of x1 as a, value of x2 as 1, for x3 b, and for x4 1, where a, b and 1 belongs to b. So B means what? Boolean algebra. So that Boolean algebra is B star XOR 1, no sorry, complement 0, 1. So again we have seen what is Boolean algebra, what are the operations associated with. So can anybody tell me why we have written here this one as Boolean algebra? So B for Boolean algebra. And what are these three? Star, XOR and complement. What is the definition for Boolean algebra? Yes, we have seen this. Distributed, complemented, bounded lattice is called as Boolean algebra. That's why we have taken here three operations: star, XOR and complement. Again, 0 and 1. Why we have taken here 0 and 1 in the definition of Boolean algebra? What does it define? What is this 0 and 1? We have seen this for lattice as well. 0 and 1. 0 means what? So 0 means what? It's lower bound or least element, and 1 is greatest element. So these two elements are there. So this is given Boolean algebra that is shown over here, and from this Boolean algebra we have to find what is the value for this given expression. So look at into this diagram. So this Boolean algebra is consist of four values: 0, a, b and 1. So can anybody tell me what is complement of 0 here?
1.
1.
Is correct. Complement of 1?
0.
0. Complement of A?
B.
And complement of B?
A.
A. Okay. So this is our given Boolean algebra. So first of all, we will see how we can solve this. Given expression is this one. So for this x1, we can substitute A because they have given x1 is equals to A. So that value I have written here. So again, value of x2 is 1. So A star 1. Now next one is star operation. Star x1 star x4. Means what? What we can write? 1 star sorry, A star 1, because value of x1 is A and value of x4 is 1. So A star 1. XOR x2's complement. So value of x2 is 1. So we have to take here 1's complement, and that is 0. XOR x3. Value of x3 is B. Star x1 complement. Value of x1 is A and complement of A is B. So all those values are given here. Take here A star 1 star A star 1 XOR 1's complement XOR B star A's complement. So A star 1, what is value for this operation? A star 1. So again, greatest to lower bound of A and 1. Value काय येईल मग?
A.
A. Okay. So that we have taken here star operation A star 1. So again value for this operation is A. XOR 1's complement. So complement of 1 is 0. That is written over here. XOR B star A's complement. So again A's complement is B. So value for this one is B star B. So again we can simplify this one as A star A XOR 0. So A XOR 0. So least upper bound of A and 0. So what is value for this XOR operation? A. So that we have written here XOR B star B. So again value for this one is B. So again we have to find A XOR B. A XOR B means what? 1. That is least upper bound of A and B. And that is A here. So A star 1. So again greatest to lower bound of A and 1. It is A. So in this way we can find value for this given expression. Otherwise there is another method. This is our given expression that we have written here. So first of all we will simplify this example and then we will put values of this x1, x2, x3 and x4. Okay. So look into this first bracket. Value is x1 star, x2 star, x1 star, x4. So here x1 is repeated. So we can consider it once. X1 star, x2 star, x4. This is our first simplified bracket. Now XOR x1 star, x2 star, x2 complement. So value for this bracket is 0. Why? Because 1 into 0. If you consider value of x2 as 1, then value for x2 complement will be 0. So 1 into 0, it is 0. So value of this whole bracket is 0. Then again XOR next bracket is x1 star, x2 star, x3 star, x1 complement. So again 1 into 0. If you consider value of x1 as 1, then x1 complement becomes 0. So 1 into 0, again it will give you 0 only. So again if you solve this second step, x1 star, x2 star, x4, XOR 0, XOR 0. So you will get x1 star, x2 star, x4. So now we can put the values of x1, x2 and x4 here. So value of x1 is A, x2 is 1 and x4 is 1. So those values are given here. A star 1 star 1. So first of all we will find value of A star 1. So A star 1 means what? Greatest to lower bound of A and 1 and it is A. So that is given here A. Again A star 1 means what? Again it will give you A. So in both the methods you will get value as A only. So likewise we can simplify given Boolean expressions likewise. Have you understood this problem?
Yes, ma'am.
Okay. So these kind of problems they have asked for 4 marks. Next question. Obtain the values of Boolean forms. First Boolean form is given as x1 star x1 complement XOR x2. Second one x1 star x2 and third one x1 XOR x1 star x2 over the order pairs of 2 elements of Boolean algebra. Means what? They have given here Boolean algebra is consist of 2 variables x1 and x2. So again, two variable means what? There will be four possible values, and those values are 0, 0, 0, 1, 1, 0, 1, 1 for this order pair x1, x2. Okay, so first of all, we have to find value of x1 star x2. So again, this star operation means what? We have to take product. So if both the values are 1, then only final value will be 1. Otherwise it is 0, just like a truth table. So here x1 star x2, 0, 0, 0. Here final value is 1, 1. So it will give you 1. Now next column is x1 complement. So here values of x1 are 0, 0, 1, 1. So if you take its complement, it becomes 1, 1, 0, 0. So that is given here. Next one, x1 complement XOR x2. Check here, x1 complement is here, x2 is here. So again, we have to type XOR operation. Means what? If both the values are 0, then only you will get final value as 0. Otherwise, it is 1. So first one is 0, 1. So value is 1. Next, 1, 1. Value is 1. Then 0, 0. So its value is 0. And then 1, 0. Again, value is 1. Now, x1 star, x1 complement, XOR x2. So we have to take product between x1 and x1 complement, XOR x2. So for these two columns, we have to take product operation. So product means what? Again, if 1, 1 is there, then only final value is 1. Otherwise, it is 0. So 0 into 1. So its value is 0. So again 0 into 1, 0. 1 into 0, 0. Then 1 into 1. So its value is 1. And for next one is x1 XOR x1 star x2. So again you have to take XOR operation between these two columns. First column is for x1 and next one is for x1 star x2. So again XOR operation means what? If both the values are 0, then only final value will be 0. Otherwise it is 1. So 0, 0, 0, 0, 0, 0, 1, 0, 1 and 1, 1, 1. So check here. We have find value for this form x1 into x2. We have found value for x1 star, x1 complement XOR x2, and we have found value for this one x1 XOR x1 star x2. For all these three Boolean forms, we have find value. So this is just like a truth table. Have you understood this problem?
Yes, ma'am.
Okay. Again, so if you observe this truth table, we can say that here values of x1 star x2 and x1 star x1 complement XOR x2 are identical. Check here. Values are 0, 0, 1. Here also it is 0, 0, 1. So that one part we can say. Again, value of x1 and x1 XOR x1 star x2. These two values are identical. That is 0, 0, 1, 1. Again 0, 0, 1, 1. and that we can prove by solving these examples that is given here. So if you consider this one, what we have seen, these two terms are identical because values of these two terms are same. X1 XOR X1 star X2, this is one term and this is equals to X1. So how we can prove this? So before that, again, these two terms are identical. That is x1 star, x1 complement, XOR x2. This is identical to x1 star x2. Check here, x1 star x2 is, it is 0 0 0 1, and this is identical with x1 star, x1 complement, XOR x2. Why? Because values of these two columns are same, that is 0 0 1. So we can prove this by solving this expression also. We can take one of this expression. I have considered here this one, x1 star x1 complement XOR x2. So here we can apply distributive law. X1 star x1 complement, this will be first bracket, XOR x1 star x2, this becomes second bracket. Now solve this. X1 star x1 complement means what? 1 into 0. So value for this bracket is 0 XOR x1 star x2. So if you add 0 with anything, you will get that value only. Likewise, x1 plus 0, you will get x1 only. So likewise, here you will get x1 star x2. So from this, we can say that these two expressions are, or these two forms are identical. So likewise, we can prove for this one, these two forms are identical and its value is x1. This is not given in question, just they have told us to find the values for this boolean forms. So that is not mandatory, just additional part I told you. Now, next question is given as, show that the following boolean expressions are equivalent to one another and obtain their sum of product canonical form. So first of all, we will think about what are the forms. Those are identical to one another. So these are four forms given here. You have to draw truth table for these four forms, and then you have to tell me what forms are identical to one another. So first is given as x XOR y star x complement XOR z star y XOR z. So from this we can draw truth table like this, and then you have to tell me what are the forms. Those are identical to one another. So take time of 10 minutes and form truth table for all these four formulas. Can you do it?
Yes, ma'am.
Okay. Have we solved it?
Yes, ma'am.
Okay, so what are the formulas? Those are identical to each other.
A and C
A and C
and B and D.
and B and D. Okay, so check here. This is the truth table for all these four formulas. A and C is these two are identical and values are 0, 0, 1, 1, 0, 1, 0, 1. Again, value for B and D. Again, it is 0, 0, 1, 1, 0, 1, 0, 1. So check here. So we can say that here all these four formulas are identical because value for A, B, C, D is same as 0, 0, 1, 1, 0, 1, 0, 1. That's why all these four formulas are identical. So remaining part of this example, that is obtain their sum of product canonical form. So all these four formulas we have to obtain sum of product canonical form. So that part we will see next lecture. So give me percentage. Roll number 1. Roll number 1 is there. Okay. 2.
Yes, ma'am.
Number 1 present.
Okay. Roll number 1 and 2 are present. Roll number 3.
Yes, ma'am.
4.
Yes, ma'am.
Yes. Hello. Roll number 4.
Present, ma'am.
5. 6.
Present, ma'am.
7. 8. 9.
Yes, ma'am.
10.
Present, ma'am.
11.
Yes, ma'am.
12.
Yes, ma'am.
13.
Present, ma'am.
14.
Yes, ma'am.
15. 16.
Present, ma'am.
17.
Present, ma'am.
18.
Yes, ma'am.
19.
Present, ma'am.
20.
Present, ma'am.
21. 22.
Present, ma'am.
23. 24.
Yes, ma'am.
25.
Yes, ma'am.
26.
Present, ma'am.
27.
Present, ma'am.
28. 29.
Yes, ma'am.
30. 31.
Yes, ma'am.
32.
Present, ma'am.
32 is present. 32 present. Okay. 33.
Present, ma'am.
34. 35.
Present, ma'am.
36.
Present, ma'am.
37.
Present.
38. 39.
Yes, ma'am.
40.
Present, ma'am.
41. 42. 43. 44. 45. 46. 47. 48. 49, 50, 51.
Yes, ma'am.
50 is present. Okay. 51,
Yes, ma'am.
52, 53, 54, present. 55, 56, 57, 58,
Yes, ma'am.
59,
Yes, ma'am.
60, 61, 62, present. Okay. 63,
Present, ma'am.
64,
Oh, yeah.
65, 64 is present. Okay. 65, 66, 67,
Present, ma'am.
okay.
66 present.
67, 68, present. 69, 70, check for absent numbers. Roll number 5, 7, 8, 15, 21, 23, 28, 34, 38, 41, 42, 43, 44, 45, 47, 48, 51, 52, 53, 55, 56, 59, 60, 61, 65, 67, 69, and 70.
हॅलो मॅम. 44 प्रेझेंट होता पण ते नेटवर्कमुळे गेलं.
44.
जॉईन झाल्यानंतर
Okay.
44.
Ma'am, 59 also present.
15. Okay. So today we will stop here. Thank you.